All right, you got 3 quizzes tomorrow. I'm doing a video. I'm doing 3 of them, and I'm doing them fast. Simplify rational expressions. We're going to factor, 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 anything that we can factor. The GCF is 5a. 5a times a is 5a squared plus 9. A plus 9 over a plus 9 is a special form of the number 1. So what's in the numerator? Just 1. What's in the denominator? 5a. Excluded values are anything that makes the original factored denominator equal to 0. So this equal to 0. A plus 9 equals 0. So a can't be 0, and it can't be negative 9. All right, so let's take out the GCF. I believe that 3 goes into... Nope. Darn, okay. There is no GCF here. Okay. So, I'm just going to straight up factor. I need to get a small number, so I need these to do 3p times 3p, and I need to multiply them by numbers that are close to each other consecutively. So I'd have like 7 and 8. And then if this one's negative, then the 8 is going to be the negative 1. And this will be the positive. Okay, and then I think there's some things we can cross off. 3p minus 8 over 3p minus 8 is a special form of the number 1. 3p plus 7 over 3p plus 7. So you're left with p plus 7. All right, okay, adding fractions got to get the same denominator. If you have a monomial and you have a binomial, your LCD, unless you can factor this, is just this times this. LCD. 4k squared times k plus 6. Both of these need to have the denominator of 4k squared times k plus 6. So I'm going to write them with that exact denominator to keep the end in mind. K plus 6 needs to be multiplied by something to get it to look like this. And that something is 4k squared. So I'm going to multiply this first fraction by 4k squared over 4k squared. And remember that anything that has multiple things in the numerator denominator, we have to distribute. All right, 4k squared times something would give me the LCD, and it appears to be k plus 6. So I need to multiply this by k plus 6 over k plus 6. Remember, groupings need to be distributed. Okay, so for the first fraction, I'm going to distribute this in. 16k cubed minus 4k squared. I'm going to distribute in the 4. Now I'm going to check, because if this is a subtraction, then I want to distribute in a negative 4 and then not have to worry about that minus. But it's actually a plus 4, so I'm going to distribute in a plus 4. 4 times k, and then 4 times 6, 24. Now you have the same denominators, so just combine like terms on the top, and we have none. Okay, so we have 16k cubed minus 4k squared plus 4k plus 24. This actually looks like it might be factorable by grouping, but really what we're most interested in is if it's actually factorable and then something would cross off, right? We don't need to factor it if nothing's going to reduce. So I see that there's a GCF, first of all, and that's 4. So I'm going to take out the GCF. We have 4k cubed minus k squared plus k plus 6. 4k. So 4. Yeah, there's no k attached, but we can still reduce the 4's at least. 4 over 4 is 1. Okay, and then we have this. Now you can see that you have a 4, a 1, a 1, a 6. They kind of need to be like the first and third need to line up with similar numbers or numbers that have common factors, and then the second and fourth. So it's not this numerator is not factorable. I can't cross off the k plus 6 because it's being added, not multiplied. So your final answer is 4k cubed minus k squared plus k plus 6. Sorry, over k squared times k plus 6. Now I know why I didn't originally cross that off. Don't forget about the k to the 6. The k squared, I mean. Okay. Wow. Keep factoring. See if there's anything we can reduce. Okay, first of all, division. We're going to change it to multiplication and flip the second fraction. So what I'm going to do is I'm going to factor the denominator above and the numerator below. Okay. So, is there a GCF? 35, 36, 32. Wow. No. There's not. Okay. So I'm gonna try to do, you know what, I just am afraid this is gonna get too confusing, so I'm just gonna flip the fraction actually. Okay. This factors, I'm gonna try 7p and 5p. What if I do 8 and 4? So 40, okay. 8, 4. All right, 8 and 4 gives me 32. If I do the 4 being multiplied by the 5, that gives me 20. And then if I do the 8 being multiplied by the 7, that gives me 56. 56 and 20 is going to give me a 36, right? Because one of them has to be positive, one of them has to be negative. 8 times 7 is the bigger product, so making the 8 negative would make that negative, would make this negative. So this one is plus. Okay, and then this one factors to be 7p times p, and then, okay, 7 plus 4 is actually 11, so I'm going to put the 4 in the same parentheses as the 7, because I don't want to multiply those. And I'm going to put the 1 in the other parentheses. This is, wow, really, really beautiful. Plus, this is a p plus 1. All right, okay. And then this one, the GCF is 8, so that's 5p minus 8. Here comes the fun part. 5p minus 8 over 5p minus 8. 7p plus 4 over 7p plus 4. Those all equal 1. And then I'm left with, this is in the numerator, this is still there, this is still in the, these are in the denominator. Okay. P minus 2 over 8 times p plus 1. Take out the GCF in the bottom, which is 3b, and we're left with b squared plus 4b plus 3. And then factor this, b times b, and then 3 times 1, add them to get 4. That's the denominator. I see that there's a b, so I'm going to, the top of this is 2b times 3b, b plus 3, b plus 1, minus 4/3. Now, the b over b, that should be multiplied. The b over b is actually a special form of the number 1, and it's all being multiplied, so we can reduce that. So this would be 2 over 3 times b plus 3 times b plus 1, minus 4/3. Now I need to find the LCD because I'm adding, or, well, in this case, subtracting fractions that are not that do not have common denominators. The LCD is definitely the biggest piece. B plus 3, B plus 1. And then check to make sure that 3 goes into this piece. If not, then we would need to multiply it to the front. But this actually can divide 3 evenly with no fractions. So this is the LCD. This fraction already has that as the LCD. But this one does not. It's missing several things. What do I multiply 4/3 by? In order for the denominator to be 3 times b plus 3 times b plus 1. Well, there's already a 3 in the denominator, so that's taken care of. So really, it's just these two binomials. B plus 3, b plus 1, and we're multiplying the top and the bottom, and I'm running out of room. I'm going to FOIL those out right now and actually know what they are because I factored from the trinomial that they came from. B squared plus 4b plus 3. And then I'm going to change this to a plus and bring this negative right up in front of that 4 just so I don't forget to distribute the negative 4. All right, we are just running out of room. So these two fractions, now I'm going to put them into one fraction. So the bottom of the fraction is still the same thing. And now we have 2 plus a negative 4b squared. Negative 4 times 4b is negative 16b. Negative 4 times 3 is negative 12. Now combine any like terms and you're done. So I'm going to write the negative 4b squared first, minus 16b minus 10 all over 3 times b plus 3 times b plus 1. And that's it. I see that I could take out a 2 in the top, but that's not going to help me because 2 won't reduce with 3. I only need to factor it further if it'll help reduce. And the final one is number 6. You have 3 denominators here. Well, you just got so many denominators because you got fractions within fractions. But as far as like the little fractions are concerned, you got 3 denominators, and here they are. So I'm trying to find the LCD of these 3 pieces. I automatically go to the biggest one. The biggest one has to be in the LCD. It might be the entire LCD. It might just be part of it. But the whole thing, the biggest with the most terms and stuff, I mean, these are all binomials, but this I can see is factorable. So the biggest thing is in the LCD. First, I'm going to factor this. Okay. GCF is m times m plus 3. Okay, so that's part of the LCD, at least. Now, check to make sure the LCD has accounted for all other denominators. Does this m plus 3, will that go into this? Yes, it will. This one? Yes, it will. So it's already accounted for. So this is truly the LCD. Now we need to multiply the numerators of all these fractions by the LCD. So really what I'm doing is multiplying by m times m plus 3 over m times m plus 3. This is 1. But if it helps you to visualize it as like levels of fractions, like the big one and then you have the upper 2 and then the lower ones, then you could put this over 1 over 1. And that kind of like levels it out I like to see all the fraction bars kind of like in line, and that makes a little more sense to me. So is this still 1? Yes, it is. Okay. Anything over 1, that's fine. So that's what we're going to multiply first. The first thing that I show you is going to be a huge, ugly looking fraction, and then it's going to reduce nicely. Hopefully. Okay, so the top of the top. We have so many things going on. Okay. Sorry, just trying to decide how to approach this. This is the big fraction bar, if that helps. I don't know, I just started drawing lines. All right, so we have one fraction on top. It's gonna be 2m plus 3. So anytime you have multiple things in a numerator or a denominator and you're multiplying, make sure you group those. And then I'm gonna say times m plus 3 over, and then write this in its factored form, m times m plus 3. All right, this fraction, I'm going to distribute this to that piece, right? When you're multiplying this in, you have to multiply it by all the pieces. So this is going to be m times m plus 3 over m plus 3. And this one will be m times m plus 3. So m squared times m plus 3 over m plus 3. And now reduce, and you should get fraction over a fraction. You won't get a fraction over a fraction. You would just get one fraction. So many fractions going on. Okay, m over m is 1. M plus 3. In the numerator, we're going to have one fraction. 2m plus 3. 1, 1. M squared plus m. All right, if this one had an m, I could put something, I could reduce, but it doesn't, and that's my final answer.